Okay. My hovercam is having a connection, of course, because I need it to work today of all days. And so I'm recording this period because it had a connection last period and would not go. So we'll see. Hopefully so. Well, I mean, we were still able to use it. We just weren't able to record, which, where's the fun in life if you can't record? I'm sorry I was out yesterday. I don't know if you know what Braxton Hicks contractions are, but I do now. So I thought things were happening yesterday that apparently are not ready to happen, which is good, because I don't know about y'all, but I'm not ready to leave you yet. There's still things I have to say. Anyway, I swear when the time really does come, I will let you know. I'll let you know, like, Miss Kaufman is going to be out for good from here on out. Or not for good, for a couple weeks.
I haven't seen any more practice subs like the one yesterday.
Well, I came to school yesterday for a solid hour before y'all got here, but the contractions did not stop. So then it was like, no offense, but every man for himself. Miss Kaufman needs to go to the doctor. So, as long as there was someone alive in the room, I'm good to go. But I'm hoping nothing like that happens again. So, whew. Anyway, we'll get it together. We're behind, which is fine. I mean, we were out a lot of days this week anyway. It's our first normal day of the week, so that's understandable. So I'm still on the first math workshop. We never went over 4 of the answers, so I want to go over those last 4. I know last Friday I gave you math workshop number 2. We'll just start that officially on Monday. If you wanted to have questions already done to get ahead in life, it's genius. If not, it's okay. Do you have out your number strip? Are you ready to roll? Okay, perfect. Okay, let's start with number 8. I'm really curious about what we're supposed to do with that negative under the radical. What are we supposed to do with that? What do we use to go to that negative under the radical? We can't have that. You want me to help you? No, not that. No, not something we didn't calculate. That's always the negative exponent. Okay. Breathe. I, right? The negative under the radical, you use I. So, like if we had negative 4, we decided that was 2I. We had this whole thing about how we couldn't have a negative under the radical, and that's how they came up with I, and so we use I to get rid of the negative under the radical. So it should be 2I square root of 67 x to the 3rd y to the 8th. And now there's still more work to do, but first things first, we got rid of the negative. Can we break down 67? It's something times something 67. Okay, so Kyla said no. Nothing times nothing is 67. If she can come up with what that vocab term is, when nothing times, like you can't multiply to it, only 1 in 67. There's a P word. Okay, and that's how 4 gets there for prime. 67 is a prime number, so we're going to leave 67 underneath the radical. Now I need help with that x to the 3rd, y to the 8th. Who comes out and how many, and to what power, and who's left? X squared comes out? Just an x. And then y to the what power? Okay. 4 and 5 get 1. Okay, if you've forgotten about the exponents, if it's an odd, we know someone's going to be left at home. If you need to do circle buddies, you can. So, for instance, x to the 3rd, I have a pair. That's how I got the 1x out. This one doesn't have a match. That's why he was left home. If you did the same thing with writing out the y's, you would do circle buddies and get 4 pairs of y's, so it'd be y to the 4. Okay, so that's number 8. And yeah, it was a little complicated because it involves I, it involves simplifying the radical, it involves exponents, but we can totally handle this. Number 9 is a little easier. 120. What times what is 120? Okay, I heard a couple, and then I know one of them was right, but we really need one of the numbers to be a perfect square. So when the numbers you said out loud, were either of those numbers perfect square? So we need a perfect square. So something times something, and one of those numbers. 4 times 30. 2 gets the point. Now, when first period said 4 times 30, I thought, that's not big enough. There's a bigger one. But there's not. 15 and 2 make up 30. We can't make that 4 any bigger. I thought it was going to be like 16 times something, and I'm wrong. Okay, so 4 times 30. So square root of 4 is 2, so 2 square roots of 30. I know my final answer has that. Now, someone help me with the x's and the y's. And you're left with one at home. Thank you, Jax. You can have a point for that. And then what about the y's? And you have a y left. Okay, I heard it from 2, 4, and 5. So 5 times 2 is 10, plus 1 is 11. He's right. 2 times 2 is 4, plus 1 is 5. Yeah, that's right, too. Okay, let's go to number 10. It's my favorite one of the day. I know there's a 10 that comes out. What else comes out? Okay, I have an I, and now what else? X or is X to the second? I heard an X and I heard an X to the second. Just X. Okay, so let's look at what you have left then. So you brought out the I, so you don't have the negative. You do have the 64. You do have an X. So we're not all the way done. So I agree with the x squared plus 1 is x to the third. Y to the fourth times y to the eighth. I agree with the x's and y's. I agree with the I agree with the 10, but there's still one more thing we can do. Okay, so what should my final answer read then?
10i x y to the fourth.
And then have 8x.
Yes, but can't you then combine some numbers to tell me the final number out front? I'll give you the I x y to the fourth square root of x.
10i x.
5 at the point. So Jackson's completely right in that yes, 64 is 8. So if I were to put an intermediate step, yes, it would be 10i x y to the fourth 8 square root of x. He's completely right saying this. There's nothing wrong with that. It's just, can't we then do 10 times 8 is 80? So 80 I x y to the fourth square root of x. So Jackson knows what he's doing. It's just, could we then combine the 10 and the 8 and make 80? And then number 12, no radicals, but we are dealing with exponents. Your gut thought on number 12, what should we do first? Okay, so we can deal with this negative exponent. There might be a better thought first, so that will work, and we will still get the same answer, but Ellie's trying to create a whole world of hurt, and we can maybe alleviate that if we did something else first. Yes, we could move that negative 3 to the bottom. And so Jackson's going to get the point because he's thinking what I'm doing. Can I maybe simplify inside the parentheses? So Jackson's already on it. He moved the negative 3 to the bottom, so x to the what power in the bottom? It's x to the fifth. 3 plus 2 is 5. Now, if you instead subtracted, well, let's 1 7 times. What's 2 divided by 12? So there's a 6 in the denominator. And then what number should be in the numerator? Y to the what power? Jack's getting another point. Okay, those of us who aren't in Jack's land today, because it is a Friday and Miss Compton's expecting a lot all of a sudden from us. So you're cool with the 6 in the bottom, because 2 divided by 12, you simplify that to 1 over 6. Great. Negative 3 minus 2, maybe you had x to the negative 5. 6 minus 1, you had y to the 5. But Jax was just smart enough to go ahead and say, hey, I'll put that -5 in the denominator. So that's how he got y to the 5th divided by 6x to the 5th. And so Ellie's strategy of starting with raising to that -2, she's really glad she tried to simplify inside first, because now raising to the -2 is not going to be that big of a deal. So if we raise everybody to the -2, so y to the 5th to the -2, I would have y to the -10, 6 to the -2, and x to the -10. What do you notice about all of these exponents? They're all negative. So what do I need to do? If I flip them all, what would my next step say? And? Okay, thank you. You can have a point. So we literally flip them all and change all their signs. 6 and x go up, y comes down. And so my very final answer is what? Yeah. So 4 and 5 get a point. 6 squared is 36. No big deal. 36x to the 10th divided by y to the 10th. And we're done. Are there any questions about this math workshop? Like I said, the one we passed out last Friday, we're just going to start it on Monday. Everyone's a week behind. It's not like we're any further behind any other class. Everyone's going to start math workshop 2 next Monday. It's fine. We won't back. Okay, let's look at your note packet. Let's talk about some things. So I am sorry I was out, but I do not want you to get any further behind. So I'm going to say scary words that you don't want to hear, like test.
Oh, yeah.
I want to say that we're going to have a test on this material on Tuesday, but I'm going to say some even nicer words that are going to make you happy. So I feel like you already had last Friday to work on the study guide, and then you had yesterday to work on the study guide. So I'm not going to give you another day of class to work on the study guide. We're going to talk about some stuff today. We're going to talk about some stuff on Monday. We're going to test on Tuesday. I say that, and then here are the good words, the non-scary words. I'm going to post the key to the study guide tonight. It would be wise that you've attempted the study guide on your own, of course, but also that you've checked your answers with the key and you know you're correct, because I'm not going to make you turn this study guide in. Here's why. You can use this study guide on the test. I'm going to let you use the study guide on the test. So I'm going to reference the study guide as we discuss some of our notes today. You can seriously use the study guide on the test on Tuesday. I'm posting the key later tonight. You can use the study guide on the test on Tuesday. Now there's a little left that we haven't talked about, which we're going to hit on today and Monday. But seriously, like 80% or higher, because you're pretty good at your graphing calculators, I could really round to 90%. About 90% of the test material you could handle. I can give you the test today. And although you wouldn't like it, you could do well on it if you focus. Okay, so those are my good words, that the study guide is not going to be a grade because you're going to need to use it on the test on Tuesday. I'm not going to give you another day of class time to work on it, though. You've already had 2 days of class. So if you were not productive those 2 days, bless your heart, it sounds like you need to get some activity happening this weekend, or this is going to be a terrible 60% grade, which is awful because it's the first in the 60. Speaking of grades, and something stinks. I haven't typed in a darn thing. I've written stuff down. I've got your points added up. I need to type those in. I need to type in your math libs. I need to type in your synthetic division. But some people still haven't shown me the evens page, the second page of the packet. If that's you, you're saved by the bell because I haven't typed anything in yet. Make sure I see that before you leave today. If you haven't shown me that, or there's something else you haven't shown me, make sure you show me today, because I swear to goodness I'm typing in stuff this weekend if it kills me. Okay, so I'm going to do a brief review, and I'm willing to answer any questions you have, especially those who've done the study guide problems. We started off in the new year by talking about long division and how great fun long division can be. If you want to look back over something, look back over your math libs. Did anyone try a long division problem on the study guide and they got stuck and they need help? What number? 12. So Ellie's you better be glad she asked for a problem. So number 12 on your study guide is about to be worked out right now. Let's make sure we're on the same page. The good thing on the notes and the good thing on the test is that not every problem has to be solved with long division. You could. And if Ellie was really stuck, maybe she should try this problem with synthetic, see what she gets, and then she at least would know what her goal is. Okay, 4x to the third minus 2x squared plus 8x plus 8. Now this is a nice problem because I didn't have to put in any zeros. Because there was an x to the 3, there was an x2, there was an x1. I didn't have to put in any placeholders. That was good. Okay, I need x to become 4x to the third. So x times 4x squared. X times 4x squared would be 4x to the third. 3 times 4x squared would be 12x squared. And then change everybody's sign. 4x to the third minus 4x to the third cancels out. Negative 2 minus 12, I get negative 14x squared. Most people make the mistake right there. They remember that the first guys are supposed to cancel out, but they forget to do negative 2 minus 12 and get negative 14x squared. So part of me wants to bet Ellie messed up there. Maybe she didn't. Okay, I bring down my 8x. Now I want x to become negative 14x squared. So I need to multiply by negative 14x because x times negative 14x is negative 14x squared. 3 times negative 14x, that's negative 52x. Okay, again, I've got to change everybody's sign. Negative 14 plus 14, those do cancel out. 8 minus negative 52 ends up being 8 plus 52, so I get 60x. And I bring down that plus 8. So I'm trying to get x to become 60x, so I need to multiply by 60. X times 60 is 60x. 3 times 60 is 180. I don't need to change everybody's sign. 60x minus 60x dies. 8 minus 180 would be, 8 minus 180 is negative 172. So sadly, I have a pretty large remainder. So I'm going to put negative 172 divided by x plus 3. So my answer is 4x squared minus 14x plus 60 minus 172 divided by x plus 3. Now let's say Ellie did make that tragic mistake right here, which is where I would guess most people make their mistake. As long as she follows through and keeps going and does the process, even if our answer she doesn't get the exact perfect right answer, I'm only going to count off for that one tiny mistake. I'm not going to count the whole problem wrong. But if she stops right there and quits, it's hard to give points. Are there any questions about number 12? Okay, then back to the notes. So I feel pretty good about long division. Like, I think we can do long division. Now, have we spread it out over 3 weeks and it's been a while, you need to look back over it? Probably. But I feel pretty good about long division. Synthetic division is supposed to make our lives easier. That's on the next page of the notes. With synthetic division, you're supposed to fly through. If you don't fly through, I don't use synthetic. There are certain problems that take me a little more time, so I don't bother to use synthetic. For 2 points, can you tell me what kind of problems I would not use synthetic for? One where I'm going to end up with a fraction. How do I know I'm going to end up with a fraction? Yes, and you can have 2 points, I promise. Okay, on number 1, I would use synthetic. There's a 1 out front, so I'm just going to end up using a 4. That's great. On number 3, I would have never used synthetic. I would have used long division. That 3 out front, it's not a 1. That 3 out front means I'm going to end up using fractions. I got to deal with fractions the whole time. Pass. I would rather just do long division. It's going to take just as long. Now, if you want to, we talk about how to persevere and go for it. But seriously, if it's not a 1 in front, I don't use synthetic. Just my personal thoughts on the matter. Are there any questions about synthetic? Was there a problem you did on the study guide, synthetic, and it just fell apart? Okay. I like synthetic. Moving on to the next page. You were supposed to have done the evens, and I swear to goodness, practicing this is going to help us today. You did already technically take a test on this before Christmas, but again, that was well over a month ago. It really was. So were there any questions from one of the evens, especially some of the harder evens near the bottom? Okay? And then after that, we got to the degree and the leading coefficient. The degree is the highest exponent. Leading coefficient is the number in front of that highest exponent. So if it's 21x to the 7th, the 21 is leading coefficient. Or it's apparently number 3. It was a negative 21 leading coefficient. Even if they're not put in the correct order, you have to look for the highest power. And then the harder ones were like 5, 6, 7, 8. We discussed my trick on how to still guess the degree. Tiling doesn't actually have to factor number 8 out, for instance. She can still guess the degree is 4 and guess the leading coefficient is 3 and call it a day without actually having to factor stuff out. I say all that to then draw your attention to your study guide, because I do have some words of warning. Let's go look at your study guide. Number 6, I think? 6, yes. Okay. On your study guide, and I wrote all over my second period and first period, I don't know why. So, on your study guide, 1 through 5, seriously, it's math workshop stuff with exponents. 12 through 19, my goodness, pick long goes or synthetic. It doesn't even specify, you get to choose. The ones I need to help you with are 6 through 11. Why do I need to help you with number 6 through 11? What's different about the direction than what we just did? And that's how 5 gets another point. So yes, you have to do the leading coefficient and the degree, but darn it, they also want number of terms. Now, I am a pretty good guesser. So I can already guess the degree is going to be 2. And I can already guess that leading coefficient. It probably, when I FOIL this all out, because I'm doing it in my head, it's probably going to be a 25. Again, I seriously am just guessing on the leading coefficient. I probably need to confirm that. I'm pretty positive with my guess of the degree. Leading coefficient, not so much. How many terms did I end up with at the end?
2.
Well, the problem started with 2. Do you end up with 2 at the end? No, I think you would end up with 3. But again, I've had a lot of math classes. So I can guess this list, and I'm normally right, but I've had a lot of math classes. Is that the way you should get this answer? By making a good guess? No. So I know I just said tiling doesn't have to actually FOIL it out in order to determine the degree and the leading coefficient. But it couldn't hurt, especially since they asked for number of terms. So if we FOIL this, it's number 7, by the way. And I combine my like terms. Now I'm no longer guessing. I'm absolutely positive, because I've actually gotten to that final answer. I'm positive the degree is 2. I know for sure the leading coefficient is 25, and I can count the number of terms. 1, 2, 3. There really are 3 terms. So even though in that section you and I didn't bother to work it all the way out, on 6 through 11, because it asked for the number of terms, really wouldn't kill you. Like on number 6, at the moment, it has 6 terms. 1, 2, 3, 4, 5, 6. But you and I both know some of those like terms combine, and so you don't end up with 6 terms at the end. So if there's math to be done, do the math before you even do this list. Okay, are there any questions about that? It's like they're taking that evens page you had to do and smushing it with the degree and leading coefficient page. Why they couldn't just do two separate sections to make my life a little easier, I don't know. Now 20 through 23 are pretty easy. You just gotta say the degree. So the only thing on the study guide you don't know how to do is the very last page still. We've still yet to say any words. And I'm not positive all the words that I get out today will make you feel great about the last page, but I'm going to try. Between today and Monday, I'm going to make you feel great about it. Okay, so we left off with evaluating. We never got to that part. So page 9 of your notes. You go to page 9. I let this kid borrow you should have borrowed my second period notes. I let him borrow my first period notes, which are not my filled in ones anyway, so mine are already filled in. So I'm going to have to keep writing on paper. Darn it. Okay. Evaluating things. So page 9, number 5, it tells you W of X is this. And they ask for W of 5. What on earth, first of all, can you see? What on earth are you supposed to do? To get a point. Everywhere you see an X. I see an X, now it's a 5. I see an X, now it's a 5. Didn't we all know, see what Paige just said? Weren't we supposed to know that? Didn't we learn that at the beginning of the year? Now, we might have to pay attention to signs and make sure we don't make any sign errors. No doubt about that. But even if Cooper makes a sign error, as long as he has the line where he shows me every X he replaced with the number he was supposed to, he's gonna get most of his points in life. Which is why I'm going to say, unless you need practice with this, you do not have to do the next problem, and you do not have to do the 4 independent practice problems on that page. I do not feel like it is necessary. I feel like you already knew all that. So you can skip them if you like. I think you already knew it. If you need practice with it, then try them. Okay, next on that page it talks about standard form and factored form, which we had put on before. Standard form is easier to tell. Leading coefficient's 1, the exponent, so the degree is 2. Factor form doesn't tell us the leading coefficient or the degree as well, but it does tell us the zeros. We already know where our graph is going to cross the x-axis. Like on this one, it would be it's crossing at -2 and -3. So we've got 3 problems at the bottom. I want to try those 3. It says find the zeros of each function. And the first one says y equals x plus 1, x minus 1, and x minus 3. What are my zeros and where are they? You can have your point. Now, if you've forgotten it ends up being just all the opposite signs, you seriously can take each term and set them equal to 0. So x plus 1 equals 0, you would get x equals -1. X minus 1 equals 0, you really would get x equals 1. X minus 3 equals 0, you really would get x equals 3. If you need to show the work in green to yourself, you sure can. So number 1 has 3 zeros at -1, 1, and 3. Okay, number 2, it says y equals x plus 2 and x minus 3, where it's 0s, not 5. Say it. Okay, thank you too. So I know where my 2 zeros are. If you need to show the work, you can. But seriously, it ends up being the opposite signs. Number 3 is potentially where you might break my heart. I'm praying this doesn't happen, but we'll see. How many zeros does number 3 have? Oh, thank you. And what are those 3 zeros? Name one positive 3 and what's the last one for you? And how are we finding these zeros again? Setting them each equal to 0. So if I set them each equal to 0, I set x equal to 0, x minus 3 equal to 0, and x plus 1 equal to 0. So I see how you got negative 1. I see how you got positive 3. But this last one needs to be 0. And you can see how ones like that could potentially break your heart. I think we already knew how to do that because we did a lot of that with quadratics, but this is polynomial, so there can be more than just 2 zeros. There can be lots of zeros. Let's go back to number 1. I want to change it and talk about those 2 words in bold at the bottom. So there are 2 words in bold at the bottom of your notes. One of them says multiple 0. And the other word is multiplicity. Darn it, math teachers making life complicated for no reason. Those words sound way harder than they are. Let's change the problem number 1. What if instead of x plus 1, x minus 1, x minus 3, what if we change that first thing to x minus 1? So I'm changing problem 1. And you realize I could probably then write it as x minus 1 squared, x minus 3. Those two would be the same thing. They're interchangeable. Okay, what are my zeros on this problem? Okay, so I've got a positive 1 and positive 3. But I thought there were 3 zeros. How come we only have 2 numbers listed? Yeah, the x equals 1 is happening twice. We got x equals 1, and x equals 1, and x equals 3. The 1 is happening twice. So a multiple 0 is a 0 that's happening more than once. So for instance, in our example, 1 is a multiple 0 because it happened more than once, meaning our graph crossed that spot more than once. And the multiplicity would be how many times did it happen? Jack's already said it was a 2, so the multiplicity is 2. So if a 0, we cross it a couple times, we start talking about multiplicity, that just means how many times. How many times we say that was a 0? We said it was a 0 twice. So the multiplicity is 2. Okay, so if you wanted another example, x minus 1 to the 5th. And if I wanted to write it all out, I could. X minus 1, 1, 2, 3, 4, 5. Okay, well, if I asked you for the 0, where are the zeros, or what are the zeros? You would tell me it's positive 1, but you would call it a multiple 0. And what is its multiplicity? Yes. So, yes, it crosses the x-axis at 1, but it does so 5 times. Okay, and then I am rebellious. So while I'm briefly going to hit on 10 and 11 on Monday, I want to go straight to page 12, so the page right before the study guide, and take what we just learned here and apply it to the graph. Now, let me add an addendum. Even if Angel doesn't understand what on God's, she does, because she answers some questions. But even if she didn't understand what on God's green earth we just did, there's no way she can mess up the graphing ones, because, hey, can I have your graphing ones? Can you love me? Give me your page so I don't get it wrong. I forgot what words I was saying. Even if Angel, I was speaking on Angel. Even if Angel doesn't exactly understand what we were just doing, she can still figure out how to graph this. How? What does she always have that I will never take away from her? I'm not taking that thing away from you. So if you type in this line, press graph, and figure out how to sketch the graph you see on the screen onto your paper, and it looks pretty convincing, you're going to get all your points. So, hence why I said I can give Jax a test today. And even though he might not feel confident that he understood degree, zeros, length, coefficient, my gosh, she knows how to graph the polynomial. He's got a graphing calculator. Okay, we're going to not focus on the degree or the leading coefficient at this exact moment. We are going to focus on the zeros. Where are the zeros on number 1? -1, +3, -2. What's something I should probably write down? It had a multiplicity of what? So I probably need to pay attention to which ones have a multiplicity. Because when I graph it, that means my graph needs to cross that spot twice. And by crossing twice, I mean it could be like a parabola where the vertex was actually that point. Okay, so, and then I'm doing this in pencil because we're going to make a better guess Monday. But I'm just assuming we need to connect the dots. So maybe, that's not connecting a dot. Maybe our graph goes up like this and then down. And then maybe it does a little loopy-doo through that spot. So a multiplicity spot probably is when my graph turns. But regardless, whatever I don't know what that M is a kindergarten M, that's for sure. I know it's going to cross at where those zeros occur. Okay, on number 2, where are my zeros? And then tell me about that multiplicity. They're both multiplicity of 2. So, again, I see a negative out front, so I'm assuming I'm going to start down here. We'll come back to that Monday. I'm thinking I need to make my loop go through there. And then I need to turn back around real fast because I need to go back through here too. So even though I really have no idea what I'm doing, I understand my graph must cross those 2 points. And I understand it's really a big deal that it crosses those 2 points twice. And by twice, I mean it's crossing from this way and it's crossing from this way. It's not like we just crossed over once. So it's got a multiplicity. A hump should happen there. Moral of the story. Something important should happen there. But again, have we talked about the degree of this? Like, did the degree on 1 and 2 match? Because their graphs kind of look similar. We didn't talk about that. We didn't talk about why I'm doing an M instead of a W. All that to come. Let's try number 3. And then I'll stop saying new words. Well, I'll say less words. Number 3. Tell me where are my zeros? 0, 4, -2, -3. This one has a multiplicity of 2. This one has a multiplicity of 3. This one has a multiplicity of 2. So 0 is not really that important. At 4, I'm supposed to cross through twice. So maybe it goes like that. I don't know. I'm starting on that end this time, just for fun. I don't know. It goes through twice. 4 is the first one out there. I know it goes through 0, but it doesn't necessarily have to be a pretty loop thing, because 0 doesn't have a multiplicity. It goes through -2. Ooh, it's a cube, so it has a multiplicity of 3, so maybe it's super important. I don't know. Again, Miss Competition is making this up, assuming maybe it looks something like this hot mess. Probably doesn't. Probably need to check on my graphing calculator. Probably need to read the directions better. But regardless, when I look at pages of paper, and she's had to graph some problems, the first thing I look at, did she put the zeros? So what if her lips don't look like mine? Did she put the zeros?
So our lips don't need to be accurate on this.
At this exact moment, no. We'll talk about how to be more accurate on Monday. But again, even if Angel didn't understand any of today or any of Monday, she's got that graphing calculator. She can see, ooh, it's super stretched on my calculator. I need to make it super stretched on my paper. Ooh, it's really close together on my calculator. I need to do really tiny on my paper. Why is this is great and I could do number 4. Why can I not do 5 or 6 like this? Yeah, so they're not in factored form. So I could either factor them, like on number 6, I can pull out an x squared and then see what can happen from there. I can factor them. Or, if I'm stuck and I can't factor them, again, no one's ever taken this away from Seth. Maybe he can figure out what on earth's going on from here. Okay, that's all the word. If you didn't show me your evens, you want to show me your evens. Or if there's something else you know you have missing, here's your chance. You see me now. Show me the things.